Okay, lesson 5.5, linear regression. Best fit line. So last time we talked about a fit line or a line of fit. This time it's the best fit line. So the best line that we can get. And that's the line that most closely approximates the data in a scatter plot. Okay, linear regression, one algorithm used to find a precise line of fit for a set of data. And then correlation, okay. We talked about correlation the last time and whether it was a positive or negative. But this right here, I forgot a word in here, and this should be correlation coefficient. And I typed this up. And correlation coefficient is the measure of how well the data models the linear equation. That was weird. Okay, so if it's weak, we have it looks like this. If it's moderate, they're closer together. Did you see how this number got a little bit bigger? And this is strong, though those points are really close. So over here, it'll tell you that if the absolute value of R is greater than or equal to 0.8, then it's strong. Now you may say, well, this one says it's strong, but it has a negative. Yeah, if I plugged in a negative into this right here, I would take the absolute value would become positive. Okay, this negative just says it's going in the negative direction. Okay, moderate is going to be from 0.5 to 0.8. Remember, you have to take the absolute value though. And then weak is going to be less than 0.5. Okay, and you put, somebody's going to say, but what about negative numbers? Again, you're taking the absolute value. Okay, so the next part of this says, the table shows Jackie Robinson's total hits during each season of his major league career. Using Desmos.com, we're going to do that in a second, to write an equation for the best fit line of data. Then find and interpret the correlation coefficient. Okay, so first things first, we need to go over to Desmos. So Desmos.com, I would tell you right now, I would log into this. I'm already logged in, but you log into here. So we're going to put in this data information, but I need a table. Okay, I need a table for this. So I'm going to come here and I'm going to put a table in, and I'm going to put, oh, but I don't want 1947. Okay, I don't want to use 1947. I'm going to say we're starting at 1947. So that means that 0 is going to be 1947. Okay, so 0 and then 175 and then 170. Then these are all going up by ones. Good. Oops. 2 and then 203 and then 3 140 and 4 185 5 157 6 oops 6 159 7 120 8 81 and 9 oops 9 98. Okay, so some of you are probably saying, I can't see any of those points. Well, of course you can't see any of those points. We have to, There they are. There are some of those points. Look at that. Okay, there are those points. Now, you may be saying, well, I can't tell what that is. They're kind of going down. Now, you can come into your settings, and instead of having the y's be from this to this, our lowest y value is 81. So we could, I'm gonna do 80. To what's our highest number? 203. Okay, so if we look at it now, it looks like this. Okay, what if you changed it from 0 to this? Oh, did it change it? 0, yes. Okay, so now we're looking at that. But, okay, it still looks funny, but could I change this? Do I really need the negative numbers on the x? Nope, I don't. Oops, I don't know why that 0, 1. Okay, so there are the zeros. Okay. And what's the highest x value we used? Oops, it didn't like that. So I'm going to change this to 0. And our highest x value was 9. So I'm going to actually change this to 10. Oh, look at that. I'm going to change this back. Actually, I'm going to change this to -5. And there's a reason I'm doing that. I'm going to change this to 0. Okay. So as I look at this, oh, that's easier to see like that. So if you change what the margins are, you can see better what it's doing. So the equation of best fit. So what you're going to come over here to do is you're going to make an equation. So we are going to put in just a generic one. But if you notice, this is y sub 1 and x sub 1. So we're not just going to put y equals mx plus b, because I want to see this as a line. So what we're going to do is we're going to change a couple things. First thing that we're going to change is we're going to say y sub 1. So you hit the shift button, the dash button that's up next to the hyphen button, next to the 0, and you put a little 1. And then instead of having an equal sign, I want to do the squiggly line that's up next to the number 1. So shift and next to the -1, or next to the 1, I have that. Then I don't want x, I want x sub 1. So I'm going to change this to x sub 1. Look at that. It gave us an equation of the line. So this is the line of best fit. It just gave us what M and B are. So how am I going to do this? I have too many things all going on. Wonder if I could do this. Oh, okay, there we go. That'll work. So right here, what's my equation of the line? Well, I have M is this and B is this. So I write over here, y equals my M value, which is -10.31515 x, and then plus 195.21818. So the next thing says, find the correlation coefficient, round to the nearest hundredth. Okay, so remember R is my correlation coefficient. So it says R equals -0.818. 0.022. Now, based on the answer for part B, does the equation model the data well? So this right here, if I took the absolute value of this number, 100th, that's this point right here. So if I took the absolute value of that, I would get 0.8. And 0.8, look up here, if it's greater than or equal to 0.8, it is strong. So that means that this is a strong correlation. So that is a pretty darn good equation that we did right there. Okay, so now we're going to do the same thing, except for this time we're using this data. So what we're going to do on this is we're going to come up here and we're actually going to turn off this, and we're going to turn this off. And we're going to come down here because I don't want you to erase it. I want you to have it for your problems for today. So I'm going to add an item and I'm going to add another table. Notice how it says x sub 2 and x or y sub 2. So I'm going to come here and I'm going to plug in those points. So 1, 59.4, 2, 64.8, oops, 3, 70.7, 4, 45.4, 5, 51.8, 6, 48.8, 7, 50.7, 8, 63.5, 9, 59, 10, 44.4. Okay, and again, I'm going to change the x-axis. I'm going to go, -2 is good. I'm going to stick with that. And then the highest x value that we did was 10, so I'm going to put in 12. That's good. The x-axis, I'm going to go from 0 to the highest is 70, so I'm going to put in 80. Look here, I put in 80, I put in. Okay, take that away, and so what does this look like? Okay, so this is what our data looks like. So I'm going to come down here, and I'm going to write my equation. Y, but we need sub 2 this time, not sub 1. We need our squiggly that's next to the number 1. Mx, but x sub 2. Oops, sorry, and then we need plus b. So here, and you can change what color. You can change the color of this if you want. You can do orange if you want. I don't care. Okay, so there we have it. There is our line. So it's wanting our equation of the line. So our equation would be y equals -1.20424x, and that's plus 62.47333. Oops, sorry, you can't see it. Okay, and then it wants our R value. So I look at our R value, it says -0.4092, but I'm supposed to round it to the nearest hundredth. Forgot to do that on the last one. So there we go. Then it's asking us, is it strong, weak, or moderate? Oops, that's 4. So if I take the absolute value of that, I'm going to get 0.41. So that's a positive 0.41. So I have to come back over here and look at this. So this is less than 0.4 or less than 0.5. So that means that this is week. Okay. So again, we're going to do the exact same thing. You know what? I wonder if I can go out just a little bit on this. Okay, so here we go. So this time it's not asking for our R value. Okay, so we're going to do this. We're going to come up with an equation, but it wants to know the estimated value in 2025. So we're going to do year 1, 2, 3, 4, 5, 6, 7. And we're going to, again, come over here, but we want to turn these off. We don't want these anymore. And we're going to do new ones. We're going to come here and we're going to add a table. And we're going to put 0, 8, 8, 7, 1, 0, 2, 8, 2, 1, 2, 5, 1, 3, 14, 65, oops, 65, 4, 17, 35, 5, 20, 38, oops, 20, 38, 6, 22, 80, and 7, 26, 71. Okay, can't see anything. So we need x-axis. I'm going to say we're going to go from, I don't know, come on, why aren't you looking? -3. I don't know what it's doing. -3. And then we're going to go, 13 is fine. We're going to go from, well, let's try 0. But we want to go up to 3,000. Let's see what this looks like. Well, look at that. There we go. There we have it. Okay, so now I need to write what is my equation of the line going to be. So again, y sub 3, squiggly line, and x sub 3, plus b. There you have it. There's our linear regression line. So what is our line of best fit? So I'm going to put y equals 254.5119x plus 778.58333. Okay, so that is our line of best fit. So it's not asking for R this time. It says, what is the estimated value in 2025? So if this is year 0, this is 1, 2. Okay, so what is year 2025 going to be? So 17, 18, 19, 20, 21, 22, 23, 24, 25, and some of you are doing this. I know you're doing it like this. So that's why I'm going to know how to do this. 16. Now, could you on your calculator have just subtracted the two numbers? Yeah, you just taken 2025 and subtracted 2009, you would have gotten 16. But I know some of you are doing that. Okay, so here I'm going to plug it in. Y equals 254.5119. Plug in 16. And then I go into my calculator and I plug in that information, 254.51. Is that 51? Yes, 19 times 16 plus 778.58333. And I'm going to get this number right here. So really this should be y is approximately 4850. And what are we talking about? Sales in millions? 77373. Okay? So it's approximately that in millions. Okay. Awesome. Okay. We're going to skip this one. We're just going to come down to this one because I need to go to residuals. Okay. So I'm going to show you something on this. We're not going to look at this right now. We're going to actually look at, we're going to still look at this information that we were doing right here. And we're going to do what's called residuals. So if you see right here on Desmos, it says residuals and it says plot. So we're going to hit plot. Okay, up here, do you see there's another column that has this. So, I didn't mean to quite do it like that. Okay, these are the residuals. Now, you notice that the residuals are plotted all along the x-axis. Okay, so what a residual is the difference between an observed y value and its predicted y value on a regression line. So what happens is if I was to plug in, I'm going to go back to this last one. If I was going to use this equation right here, and plug in year 0. If I was to plug in year 0, I would get 778.583333. Is that what I have right here for year 0? No, it's not. So if I was to take 887 and subtract out 778.58333, okay, I would get this point right here. And look at that. It says 108.1. Look at that. All I did was subtract the two numbers. That's how they're getting the residuals. So in order to get this line right here, they are taking the actual amount, these numbers that are in your table right here, they're taking these numbers and they're subtracting if you had put in these values for x. Okay, so I'm going to put this down here at the bottom. Residual for this. I would have taken, it's taking the predicted, or no, the actual and subtracting the predicted. Sorry about that. So I'm going to take the actual for 0, which is 887. I'm going to subtract. If I was to put in 0 for this, I would get this number right here. So I would get 778.58333. And when I subtract those two numbers, I get 108.41667. And then I would plot it right here. And that's all that a residual is. So we're going to come over here and we're going to do the residual for this. Okay, last one. Oh, I want to turn these off. I don't want to X them, I want to keep them. Okay, then we're going to come here, we're going to make a table again. This is year 0, 1, 2, 3. And the reason I'm doing writing above for each one. I just want to make sure that they're actually going up by ones on that. Give me a second because I turn my light back on. The lights turn off after 15 minutes. Okay, so now we're going to come here, and this is how I normally do it. And I just go down to the number because it just makes it easier. So then here I can just put in 35.68, 36.78, 8.10, 2.26, 44.4, 4.7, 49.20, 49.8, 49.4, and 49.41. Oh, I messed up on something. I messed up somewhere. That's 1, 2, 3, 4, 5, 6. Oh, 8, 9, 10. That's hilarious. Okay, so those lines are, those dots are plotted. So I'm going to go from the x-axis, goes all the way up to 10. That's good. So we're going to take this, and we don't want the negatives. So we're going to go from 0 and go up to, what, 50? Nothing's over 50, right? Oh, maybe I'll make that 55. Okay. So here's my data right here. Okay. So I'm going to come down here, and I'm going to make my equation. Y sub 4, squiggly, mx sub 4 plus b. Okay. And here's my equation of the line. So my equation is y equals 1 point, I should actually be doing approximately. Okay, 1.49609 x plus 36.24136. Okay. Then this is my residual plot, and that's down there. Okay. So this says the table shows the average price of 10-person Thanksgiving dinner from 2004 to 2014. Determine the best fit model of the data well by graphing the residual plot. Okay, so this is the residual plot. Now, how did they find that? What they did when they found that is, remember, it's actual minus predicted. So what they did was the actual is 35.68 minus, and if I took my, zero amount, if I plug in 0 here, we'll get 36.24136. So if I take my calculator and I do 35.68 minus 36.24136, I would get, trying to write it and so you can see it at the same time, I would get negative 0.5636. Oops, I forgot the 1. And if I look over here and I look on this dot right here, click on it, look, the exact same information. So again, what you do is you take the actual amount, which is 36.78, and then remember, if I'm plugging in 1, all I need to do is add these two numbers to get my predicted. So 1.49609 plus 36.24136. And that's the number I get. So I'm going to write that down. 37.73745. Now, hopefully you know how to use your calculator. So I'm going to take 36.78, and I'm not going to retype all that. I'm going to hit minus second answer, and I get this answer, which is negative 0.95745. And look, that is that point right there. So that's all you have to do in order to find that. Also, make sure that you come up here to the top. Why is it not letting me name it? Oh, there we go. I have to click in here. We're going to name it. We're going to say Notes 5.5. And you have that saved.